Let me start off with some thoughts of my own around what are some of the critical challenges in the data center beyond the physical layer, I think, that we talk about. I think many of you talked about the hybrid cloud. I really do think that that is one of the primary challenges that we're looking at. I define it in two dimensions. One is folks, all of us, that are struggling with traditional infrastructure and how to make converged infrastructure work with it. That's one element of it. And the second one is obviously how do you make hybrid cloud elements, which is public and private, work together? How do you separate out the workloads, all of the things that go on in there? The other thing that I think that is really defining our time is infrastructure as code and automation, right? I think that age is really upon us. If you look at it right now, I like to use this analogy called, in automation, a journey from tools, which is sort of like we've all had that, to power tools. So it's still not completely automated, but I call like things like Puppet and Chef actually power tools. Like you have really power tools and you can do a lot of damage with it in some point. And then robots. Robots meaning no tools, it actually configures itself. And I think many in the cloud space have gone through that journey. Question is where you are in that journey and how do you engage there? So the second one is the world of virtualization at every layer is upon us. Everything is an API. And I think it's a phenomenal time to be in infrastructure, right? Where truly software-defined approaches are now permeating at the infrastructure layer. The next one I think is obvious, right? I think you see that in the news every day. Guys like us and gals, we stay up worrying about security and availability at every dimension. What are the layers at application level that you should be doing in security? What is infrastructure level? And what is the intermediation between those two? And then one question that I actually have, are they the same side of the coin, availability and security? I'm one that believes that they actually are. But that's for dialogue at a later time. And the last, actually, I think it's about people. It's about transitioning the organization from where you are into the world of tomorrow. I think the world of DevOps, we used to talk about it quite a bit back then. But I think there is a know and a do gap. I think everybody in this room know what you need to do. But sometimes when you look at the organization, there's a gap about the do part. And how do you actually do that? And the reality is that the developers and the product owners, their experiences are actually defined by what you see in the consumer world. And frankly, in terms of what the cloud providers are actually offering in a completely API-driven world. How are you going to guide your organization and the capabilities and skills through that? And then truly bringing developers and infrastructure people together in this world called DevOps, where there is not necessarily the boundaries and silos, but it's one that comes together as a whole. So that's my opening thoughts, and then I'll turn it over to Andy, and I'm sure he has some pretty interesting things to talk about.
Great, thank you. So I don't know how many of you are trained Cisco engineers that know how to configure a switch or a router. But the picture on the upper left is what that would look like. And if it looks like a throwback to the 80s, it is because that CLI command line interface was actually developed in the 1980s and hasn't changed ever since. But to put this in economic perspectives, when you get a new switch into your network, it will take you an average of, for a trained person, it is at least an hour, maybe longer, depending how, what all the ACLs are, to set it up correctly. And God forbid you made a mistake. That would be fatal because then the whole network would sort of blow up. Now, this is how networking was installed for the last 20, 30 years. And it's a highly immobile and inflexible and static thing. And one reason that the networking people always blamed for being the ones that slow everything else down is actually the pain associated with making any change to the network. Now, in the cloud, when people deploy thousands and thousands of switches, that obviously doesn't work. They're not going to hire hundreds of CCIEs to manage these networks. And as you heard earlier from Sri, when you install these racks, you want to basically roll them in, turn them on, and they should arguably self-configure. Well, we actually developed this specific capability, which we call zero-touch provisioning, for eBay. I can admit this here because they really insisted they're not going to hire any more trained engineers. And it wasn't actually that difficult. It took advantage of the fact that we had Linux on the switch, and we mapped the configuration to an URL, and it pulled it down from a central server. But from a use model, it truly saved an enormous amount of cost. And somebody quantified it, I don't know who, but over a network of 1,000 switches, it saved over $2 million a year just on the initial setup configuration kind of things. So when we think about automation, it's primarily three elements. So one is the initial configuration when you put it in, or in case you have to replace a switch, to make sure that the replacement auto-configures as well. The second one is, if something goes wrong in the network, which sometimes it does, what's the degree of visibility you have? Well, historically, you had SNMP, and you said, oh my God, there's all these bad packets, the transceiver must be going bad, and that was sort of the level of diagnostics. Well, that's not good enough anymore. When people lose traffic, they want to know exactly why it happened, where it happened, was there a bottleneck, go down to the root as quickly as possible in real time. So we added a number of tools to let people see inside the switch, again, in millisecond kind of response time. And then we export all this to Splunk or other systems. You can actually aggregate this across your network and log it all up. And then the third element is with VM environments, which isn't necessarily what people do in the cloud, but if you have mobility, then the static nature of a traditional network completely fails you because it's not mobile, right? So if a VM moves, the security profile that's associated with that machine has to move as well. And it's basically an interplay between the VMware ESX kind of layers or OpenStack or whatever your favorite environment is, and what the network setup is, and we provide all the hooks necessary that actually works automatically. But basically, what this requires is a degree of programmability at the level of the switch which didn't quite exist before, such that both external applications can program the switch to do the right things, and that we can actually interface to these external applications to export all the right things. And that really greatly reduces the number of engineers required to manage a large network, to the point that these large clouds, which is our primary customer base, can do their job remarkably efficiently with fewer network engineers than you would typically have in a much, much smaller data center. So that's what we do.
Good afternoon. Raging Wire is a multi-tenant data center company. And what we are seeing from our customers is, using the word we've talked about all afternoon, hybrid. Hybrid is the new normal. And we define hybrid not as public cloud, private cloud, but really the combination of enterprise, public-private cloud, and co-location. And we're seeing that almost every one of our customers has a combination of all three. And so when Bashir asked me to look at the vendor landscape, the landscape is very wide and it's very muddled. And there are two diametrically opposing plays going on. There is the desire for our customers to commoditize everything. You want the cheapest price you can get when looking at cloud. But you also want the services. You want the APIs. You want the automation. And that's also true of the multi-tenant co-location. You're wanting more and more data from your vendors. And so what really distinguishes the various companies, both cloud and colo, is the tools, the services, the data, the reporting that they provide you. It's really the ecosystem that you're joining when you join those. And because the rules haven't really changed, even though we're redefining what a data center is, you're still worried about security, you're still worried about availability, you're still worried about speed and price. It's just the way you are accomplishing that is changing. And the last thing I'll say is, when looking at public cloud, it's not enough just to look at the cloud. You have to look at where the cloud lives as well, the underlying data center that it is under. You see this with Amazon, where they have availability zones and reliability zones, because they, in their T's and C's, they expect that an individual availability zone can go down. And that works if you're large enough that you can spread your application across availability zones. But when you can't, even though you're in the cloud, you're in one facility or two facilities, then the underlying availability of their providers matters as well. And so what we tell our customers is where your data lives matters.
Thanks. So Raj talked about infrastructure as code. I'd like to turn that around slightly and talk about software as infrastructure. We had a few speakers in the earlier panel refer to this tangentially, but when Google, Amazon, and Facebook designed their data centers, they essentially threw out the existing playbooks for data centers, right? Instead of adopting hardware-centric design that relies on ever more powerful servers, storage, and networking, they built their systems out of commodity servers, commodity x86 industry standard servers, and built embarrassingly parallel data centers that you scale out by just adding one of these units at a time. You want more performance, add one more unit. If you want more capacity for your storage, you add one more unit. On the storage side, none of these data centers really adopted the traditional storage arrays in any real manner. It's all built around direct attached storage, and then using a software layer to tie it all together, to share and pool resources together. And then Andy talked about the automation side of things and the analytics sides of things. And this is, again, using software to make things appear as, to make things much more manageable so that you can have 10,000 servers for a single admin, which is very different from traditional enterprise IT. The systems were built to be much more resilient. Hardware by itself will fail. The hardware is not what's resilient. It's the system as a whole that's resilient. You have enough redundancy in the system that software can heal it if things fail. It's expected that things will fail. We call it, hardware eventually fails, software eventually works. Now, Google, Facebook, all these guys solve this problem for specific use cases, right? So for Google, it was for search indexing. For Facebook, it was messaging protocols, things like that. What the techniques they use, though, turn out to be surprisingly generalizable. What we have built with really scale-out NoSQL databases with MapReduce frameworks, these can be used at the infrastructure layer, and we now have a new wave of vendors who are building products around these technologies, which let you take all the stuff that Google and Facebook do, not have an army of programmers, and build out infrastructure in exactly the same way. So Nutanix is one of them. We build storage products that have the attributes that I talked about. It's completely scale out, uses commodity hardware with attached storage, and is resilient to failures and very easy to manage. So in my mind, we're at the cusp of an era where you can actually take web scale IT and move it to the enterprise data center, to the mainstream data center.
Great. My name is Michael Enescu. My official title at Cisco is CTO for open source initiatives. I head up all of the open source defense, offense programs, initiatives that we have in the company. Cisco has come a long way recently. We're no longer just a router or switch, a core networking equipment company. I think we rose rather quickly in the, the blade, the data center. We now, when we actually classify revenues or talk about revenues, we no longer talk about just routing or switching. We have the data center that we care quite a bit about. It's definitely a world of hybrid clouds. We've seen this. I think we all understand the sort of the impedance mismatch between, say, for instance, Moore's law and Nielsen's law. So the exponential growth for compute and storage versus the not so rapidly evolving ability of the edge of the network to consume all of that information. What we see is that, yes, we are in a big era of cloud compute, but as we grow forward, the data piece, I love the eBay slides, by the way. Tremendous growth in the middle. The ability to consume on that little mobile device that initiated actually the transaction of buying the car, we're going to see an impedance mismatch over time. So what that will mean is that clouds, we call them foglets or smaller clouds, private clouds, if you will, the importance of security, privacy, the ability to actually consume and scale and move this data around become extremely important. Andy made an excellent point about the slowness of evolution of the CLI and the automation. We understand that. We're working very hard on that. Very interesting thing. We just finished 2 days in Santa Clara, the Open Daylight Consortium. This is hosted by the Linux Foundation, where we took the actual, SDN, NFV, network function virtualization mantra, which sort of rides today in data centers, and we see that across service provider as well as switching and data center. Open source is eating the hardware world. It's the biggest disruption we've ever seen. We had just about 30 companies were fierce enemies in special purpose compute, right? Networking companies. Fierce competitors in the general purpose compute, right? HP was there, Microsoft was there, IBM was there, Dell was there, Google, Facebook. The collaboration that's going on, we see a new layer in here that makes the cloud, a hybrid cloud, more amenable to automation or management. The notion that you separate control plane from data plane, the notion that there's a set of people, to the point that Andy made about those network specialists or protocol heads. They understand the southbound, the things that control their data plane very well, versus the people that actually care about the business side, the northbound, the applications, those that worry about how is it managed, how is it virtualized, how is it automated, how is it provisioned. So on this slide, you see the sort of the recognition in our company that we have an acronym for this, MSDCs, Massively Scalable Data Centers. We care deeply about, the way Facebook, Microsoft, Azure, Google, Twitter, and all of these companies, eBay, of course, run their data center. And we want to make sure that we ride that curve the way the cloud, private or public cloud, gets deployed. We see security as a tremendous opportunity for all of us to do that correctly, particularly as I talked about the impedance mismatch on the data or the cloud gets computed at the edges, not necessarily in the middle of the network.